Hello, we are in Chapter 6, Section 6.3, Solutions of Quadratic Equations. In this video, we're going to go over problem number 10, in which we are to solve the following quadratic equation by completing the square. As you can see, this equation is written in the form with 0 isolated, and on the other side we have the polynomial in descending powers of the variable simplified. So it would be very easy, for example, to use the quadratic formula, but we are to review the method of completing the square. So to remind you, the idea is to present our equation as the square of a binomial on the left-hand side and just a number on the other side. So we're going to start with adding 5 to both sides to get x squared plus 8x equals 5. And I'm leaving myself room to complete the square on the left-hand side. As you can see, the leading coefficient is 1, and in such case, what we're missing to get a perfect square trinomial is the square of half of the coefficient by the first power of the variable, in our case, x. So that coefficient is 8, half of 8 is 4, and 4 squared is 16. So we add that 4 squared to complete the perfect square trinomial, and we also add that 4 squared, which is 16, to the other side to keep the balance in our equation. And then we factor the left-hand side as the square of x plus 4. The sign in the middle must match the sign by the middle term in the trinomial. And on the other side, we get 21. Now we can use the square root principle. If the square of x plus 4 is 21, then x plus 4 itself is the plus or minus square root of 21. Now 21 doesn't have any perfect square factors, so it's just a matter of subtracting 4 from both sides to get x equals negative 4 plus or minus the square root of 21. And we can, as always, split it into the two solutions, one with plus, one with minus. So we're going to get x equals negative 4 plus the square root of 21, or x equals negative 4 minus the square root of 21. Always or between them, and those are our two solutions.